Hi everybody, Mrs. Pesic here. We're looking at number 26 from section 3.5, and this is finding the exponential model that fits the points shown in the graph. If we're looking at the graph, it sure looks like an exponential growth model, which is why we would want to use this model that we see here, y equals a times e to the bt. And we don't want a negative there, because if there was a negative in front of that b, that would indicate an exponential decay. So again, assuming b is positive, we don't want a negative in front of that positive b. All right, so in this case, let's plug in some things and see where we're at. I know that, for example, we could start with x being 0 when y is equal to 1/2, and that's not even showing up at all. So let me clear that off the screen. So I know that if x is equal to 0, y is equal to 1/2. So I'm going to plug in 1/2 equals a times e to the b times 0. So really I called it x, but I guess I could have called it t. And so now we've got to solve this equation. We're trying to find a and we're trying to find b for this model, right? We need to have those values. And so, whoopsie, and so in this case, b times 0 is just 0, so I get 1/2 equals a times e raised to the 0 power. And anything to the 0 is equal to 1, so that tells me that I get 1/2 equaling a times 1. So now I know that a is equal to 1/2, right? A times 1 is equal to 1/2, so I get a equals 1/2. All right, so far I think we can write our model as y equals 1/2 e raised to the bt. So we found a, but we still need to find b. And we're going to need to use this other piece of information here to help us with that. I know that when t is equal to 4, y is equal to 5. So I'm going to plug those in to our equation, and I'm going to write 5 equals 1/2 e to the b times 4, and I need to solve this equation for b. So I can divide both sides by 1/2. Actually, I would prefer to multiply both sides by 2/1. When I do that, that 2 and that 2 divide out, and 2 times 5 on the left gives me 10. So I get 10 equals e to the 4b. I just rearranged the b times 4 as 4 times b. And now I'm trying to solve for something that's locked in the exponent, so that means I do need to rewrite this in log form. So I'm going to write log to the base e of 10 equaling 4b. And log to the base e of 10 is the same thing as ln of 10. So I get ln of 10, that's supposed to be a 10. Don't know what that looks like. ln of 10 equaling 4b, and I'm going to divide both sides by 4, and let's get a decimal answer for b. I want ln of 10 divided by 4. So control divided by ln of 10 over 4, and I'm getting 0.575646. And 0.575646, let's keep all those decimal places. So 0.575646, I think that was it. So now we're ready to write our model, and our model will be y equals 1/2 times e to the 0.575646 t. I think that's going to be our best answer here. All right, and that's it for this problem. Thanks for watching.